big in it, or there is no much difference between minimization and the maximization, except 1 point. Except 1 point. So here I'm going to give you one of the uh, uh, one of the equations so that we can find the maximization. So we have here, we have it's OR, as always it is. And for today's, we are going to look to the minimization. Let us have these equations here. Mini z, let me call as a mini z. This mini z, let me say, is equal to 5x1 plus 7x2. And this is the subject to constraint. These are subject to constraint x1 plus 3x2, they are greater than or equal to 6. And we have 5x1 plus 2x2. These are greater or equal to 10. And these should be x1 comma x2 should be greater or equal to 0. So these are our equation which we want to solve. As you can see, we want to find the minimum cost for our objective function. Clear? So the objective function for us is to minimize the cost. All right, to minimize the cost. So the first things which we do, as you remember, we have to convert this equation, this inequality into equations. Clear? We are going to convert this constraint into equations. In which way? We say we say solution. Let's say this is a solution 1. When we want to convert this one, remember this is equation 1. This is going to be equation 2. And in this regard, you're going to take this as equation by taking x1 plus 3x2, okay, they equal to what? To 6. The second equation, 5x1 plus 2x2, okay, they equal to 10. All right, this is the equation which we want to convert for equation for 1 and for equation 2. Clear? Fine. Next, number 2, what we're going to do. Number 2, the next step which we want to make, we want to find the points, the coordinate points, or the points which can formulate the straight line. Okay? We want to know the points which can make our straight line from equation 1. All right? Based on equation 1, I'm going to try to make it straight away. Okay? In this last straight away, we have x1, x2. Let me call point x1. This is x1, comma x2, okay, comma x2, so that we can formulate the points. This is the coordinate which is going to be here. Okay, let me give enough space here. Okay, when x1, remember we are dealing with the first equation. This is the first line, first equation. When x1 is equal to 0, what is the value of x2? I want you to unmute yourself so that we can go together, okay? You can unmute, no problem. I will tolerate any noise, okay? So when x1 is equal to 0, look to the question 1. When x1 is equal to 0, what is the value of x2? The value of x2 is equal to? This is x2.
2.
2, good. Now, when x2 is equal to 0, what is the value of x1?
6.
6, excellent. So here we have 0, comma 2. What do we have here? 6, comma 0. So this is the first coordinate which we find, or the first line which we find. Clear? So now, allow me to also to do for the second equation. Okay? For the second equation, let me put them here. This is 1. This is a 2. For the second equation, what do we have? We have the same. For the second equation, we have the same, where we have x1, x2, and we have the coordinate x1, comma x2. These are the coordinates which we have here, where x1 is equal to 0. What is the value of x2? x2 is equal to 5. Are we together? Yes, 5. Where x, now the coordinate we have a 0, comma 5. okay, 0, 5. Where x2 is equal to 0, where x2 is equal to 0, what is the value of x1? X1, the value is 2.
2.
The coordinate we have is a 2, 0. Correct. 2, 0. Now, once we're done to do this, what is next? Next, we want to plot these points into our graph. We want to put these points into our graph. Remember, keep in mind, we are dealing with minimization, all right? So let me try to put a small graph here for your concern, a small graph here, okay? Let this be a small graph here. I try to minimize as much as I can, okay? Now, we have this is the coordinate of, this is x1 axis, this is going to be x2 axis, all right? X2 axis, all right. So what we're going to do, we want to place our points on our coordinate. As I told you from the previous class, I mean from yesterday, when you look to your point which you have, you can keep any interval, okay? As my knowledge, as my point which I have here, as you can see, the highest is 6. So if I keep the interval of 2, that is B2, that is B4, that is B6, it's okay, no problem. I mean 5, it can be like in between here. Okay, 2, 4, 6. Now, let me also come again. Let me also come to this one. Okay, let me come to this one. Let it be 2, 4, let it be 6. Clear? 2, 4, 6. Correct. Excellent. Now, we want to look to the first coordinate. We have a 0 and 2. Where x1 is equal to 0, now we have x2 is equal to 2. Okay? Is equal to 2. Correct. Now, when x2 is equal to 0, x1 is equal to 6. x1 is equal to 6. We have a 6 here. Correct. Now, what are you going to do? We have to draw a straight line. We are going to draw a straight line. Let me use the second marker. I don't know if it will be possible, but for you, you can use a scale. You can use a scale to draw a straight line. Let me try to have it like this way. Okay, like this is a straight line. Okay, this is a straight line. You have to name all your lines. Okay, let me name this line as 1. Okay, I name it as a 1, or you can keep your equation so that you can know. Correct? You can keep your equation here to the line so you can find what line is that one. Correct? Now, the second thing, we want to draw the second line. We want to draw the second line. Second line says when x1 is equal to 0, x2 is equal to 5. x2 is equal to 5. Let's say 5 is here. 5 is here. When x2 is equal to 0, x1 is equal to 2. x1 is equal to 2. So I'm going to draw the line here. This is going to be the line, a straight line here. Straight line here. Now, the next stage is important. We want to confirm which area to shade. Which part of the line? As you can see, the line, if I have this line has 2 sides, okay? Has above the line, has even below the line. Even if I have this, there is a below, there is above. Okay? Is it clear to you all? All right? Yes, Smithon. All right? So as you can see, this is what we're going to do. We want to find where do we shade? Where are we going to shade? As a first step, second step in graphical method, we know that when you have the sign which is x is greater than this coefficient which you have here, 6 and 10, or any number which you may have here, where are we supposed to shade? Which side? Above the line or below the line? When it is a greater? When x is a greater, where do we shade?
Above the line.
We shade?
Above the line.
Above the line. Excellent. So we have to shade above the line. Now, as you remember, yesterday we did one important point to know how to shade when you have like negativity or negative variables. We are going to apply the same way here so that it can be well understood by all of you. All right. So now allow me to erase this because the purpose of these small tables are done away. Okay, are done away. As you can see the sign here, you can decide. You can say, okay, for the first constraint, we have to shade above the line. Correct. Correct. It's very correct. Very correct. But for the sake of understanding how all these things happen, we have to make it properly. Okay? We have to know how it works. All right? Because not always the sign will work. Some cases, this sign will not work. Okay, some cases this sign will confuse when you have like negative variables. So now let's do the same. Yesterday, as you remember, the step which we have done, what was that? The step which we have done, we have also solved the inequality. Okay, for yesterday's equation, we have solved also for this inequality. Okay, how did we solve this inequality? We said, okay, same here. We said, hold on. Okay, we said that these inequality are going to be solved also by taking x1 plus 3x2. They are greater than 6. Why don't we make as equal? Because we may have like a negative coefficient here at this side, by this side. Okay, we may have like a coefficient which is, or limitation which is what? These are the limitations. The limitation which may be what? Negative. Remember, x1 and x2, there should be a positive integer which are above 0. So there we go. So here, if we say here, if x1 is equal to 0, then what do we have? Then 3x2 is greater than 6. Now, x2 is what? Is greater than 2. Greater than 2. So, where is the axis of x2 on this our plot? As you can see, this is, as you can see, hold on 1 second. As you can see here, the number x, all numbers, x can represent any number. Are you following? X can represent any number, any given number. Any number which is above 2 on our axis, this x-axis, where are they? Above or below? As you can see, here we have 2, right? We have a 2. So all the numbers which are above 2, they are here. That's why the way we have to shade the up, okay? There should be up. For the second, if x2 is equal to 0, then x1 is higher than or should be greater than 6. Okay, should be greater than 6. Here we have x1. This is axis of x1. As you can see, this is the axis of x1. Okay, 6 is here. All numbers which are above 6, which side are they belong? They belong to the line which we have here. They belong above here, this side. Okay, that's why if you want to shade, we shade all here, above. Second equation, you also do the same. For the second equation, you do this, you solve this inequality equation. Okay, you solve for the second inequality equation. Okay, for the second inequality equation, we come to the 5x1 plus 2x2 is greater than 10. If x1 is equal to 0, then x2 is greater than 5. So now, which side to shade? All numbers, okay, all points, which one? Yeah, this is 5. 5 is here. All numbers which are above 5, they are where? They're above the line. Should be above the line. You keep this sign, you keep this arrow to allow you, to enable you to remember where you're going to shade at the end, okay? When x2 is equal to 0, then what's the value of x1? x1 value should be greater than 2. This is a simple mathematics which all of you know. this 10 divided by 5 is equal to 2. Okay, so then it should be greater than 2. So the thing which are above 2, where is the 2? 2 is this one. 2 is here. All numbers which are above, they are here. As you can see, if you shade, let's shade the first line. Let me shade the first line. As I shade the first line here, as I shade the first line, as you can see, all should be above. All should be above, 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 above. This is the first line, right? First line. Second line also. Let me use different lines. Okay, all should be above the line. All should be the above the line. All should be the above the line for the second line. This is above this line, above this line. As you can see, there is a point of intersection, or there is a region where two lines, they can join. Okay, the sides where two lines can join. As you can see, for the second line, look, this second line does not belong to the below here, but it belongs from this line. This is the second line, the second line here. So our solution, or our feasible solution, remember, we want to find the feasible solution. The feasible solution is going to be between 6.60 here, means the 6, 0. This is, let me call it A, and they come to B. This is, no, that's not this one. Here, it comes here, and it goes up here. And this point, let me call this a B point, okay, which we don't know. This point we have to calculate, and we come to this C. We come to C. C, what is a C? C is a C. We have this point C is 0 and 6. 0 and 6. So we want to find which point can satisfy our minimum cost.
0 and 5, sir.
Okay, which one? 0 and 5?
It's not 0 and 6, sir. 0 and 5.
0 and 5, correct. Correct. C is a 0 and 5, right? Is correct? Okay, because of these different pens or different marks. Okay, 0 and 5. Fine. No issue. 0 and 5. Correct. Let me confirm with what Suya said. I hope, is it confirmed 0 and 5? When X, which one? Yeah, for the second line, yes. When X, 5. When, 5, true, it's a 5, correct, thank you. 0 and 5, so we have a 0 and 5. Now, as you can see, we want to find this point B. We want to find this point B. If you have your graph sheet or graph paper, you can locate and find what's the value of this one, okay? You can find, and you find where it is falling. Or else, if you don't have, you can solve these two equations, okay? You can solve these two equations, and then you come to conclude what point is going to be this one, okay? If I try to solve this one, which one did I give? If I try to solve this equation here, as you can see, for this point B, for finding the value of point B, okay? For finding the value of point B, okay? How are you going to find this one, okay? How are you going to find this one? All right. The way you're going to find this one, we may say if, okay, let's say if we want to do this, we want to do x1 plus 3x2, okay, is equal to 6. All right. 5x1 plus 2x2 is what? Is equal to 10. Now I'm going to multiply the first equation by minus, let me minus this one. Yes, let me minus this one, minus 2, okay? And I'm going to multiply this by 3, okay, by 3, so that I can solve it. So when I multiply this, is going to be minus 2x1 minus 6x2 equal to minus 12. Here is 15x1 plus what? Plus 6x2. This is equal to what? This is equal to 15. Okay, 15, correct? No, 30, 30, 30, 30. All right, this plus and negative, they're gone. And then we remain with what? Minus 13x1, okay, which is equal to what? What is the value of this one? 30 is going to be equal to 18. So what is the value for this? Is it correct? No, this is plus 15, plus 13. No, plus 13 because it's a 15. So here x1, what's the value of x1? 18 by 13. Okay, as you can see, x1 is the value of x1, right? x1, 18 by 13, we have like 1 point something, okay? What is that? 18. Let me try to divide and we see. Divide 13.
1.2, sir.
Yeah, we put 1, 13. We put 2. Is remain, oh no, remain with the 5. Okay, we put point, okay, here we put 2. 0, it's going to be 36. Okay, fine, 36. Is it 36? If you put 4, it will go above. Okay, 1.2. So as you can see, x1, it is like 1.2. It is like here we have like 1.2. So for B, as you can see, B, we have 1.2. Now we want to substitute 1.2 into one of our equation here. Okay, let us substitute in the first equation. 1.2 plus 3x2 is equal to 6. All right. Now, if this goes to this side, what we're going to have? We're going to have a 3x2. Let me erase this side for the proper writing. Let me erase this side. Okay. Let me erase this side. And we have 3x2 is equal to what? What is the value for this one? Okay. 6 minus 1.2. Now, x2 is equal to what? This is going to give what value? 4.8, right? 4.8 divided 3. What is the value for this one? Is equal to 1 point something, 1.6, right? 1.6, let's say 1.6. So as you can see, x2 is equal to 1.6. You see here, you can locate this one, 1.6. So it's a 1.6. So 1.2 comma 1.6. Now we want to find, now we want to do what? We want to substitute this into our mini z. Okay, let's see now. This is important, is the last one. This is the last answer for this. Okay, what do we do? I hope I'm going a bit slow so that you can get it. If you get lost, please don't hesitate. Even you can text and then I can read your question, okay? Now we want to substitute ZA. What is ZA? ZA, okay? ZB, Z, what? C. ZA, what is a ZA? When A, remember Z, this is Z, okay? That's Z, okay? A is equal to, X1 is equal to 6 means 5, okay? Multiply 6, okay? Plus 0, x2 is equal to 0. So means 7 into 0 is a 0. We don't need it. So the answer for this one is what? Is 32, 30. Is it correct? Am I correct? Yes, 30. All right, fine, 30. Now come to B. Come to B. What's the point B? Point B, x1 is equal to 1.2. What does it mean? We mean 5 into 1.2 plus what? 7 into 1.6. You can do it, calculate fast and tell me. Do calculation, fast calculation, and tell me the answer for that one as I go to C. What is a C? C is 5 into 0 plus 7 into 5. Okay, for this one, answer is 35. What is the answer for this one? For B? Answer for B. First, use your calculator, please. Do fast. What's the answer for this one?
17.2.
17.2. Okay, the answer for this one is 17.2. Correct? This is for B. Right. Now, as you can see to our graph, if it is correct, as you can see to our graph, which is the minimum point, or which is the minimum, as you know, this is called the feasible region. Okay, feasible region. This is known as a feasible region. Means where we can reduce our cost should be belong from this point. from this point. Now, which is the minimum? The minimum obviously is B, because B is what? B is lesser than, B is lesser than ZA, B is lesser than ZC. So which means that now the final answer we do like this, we say hence, should be important, hence, okay, AX1 is equal to what for point B? For point B. For point B is X1 1.2 and X2 is equal to what? 1.6. Then we mean that and optimal solution, means the optimal solution, let me call it like this. Optimal solution is, what is optimal solution? Optimal solution is Z what? B, which is equal to 17.2. 17.2. So our final answer should be like this way. You have to mention those point of coordinate which can give us what? The answers. As you can see, also these are the answer, but this they will give us the highest, and we need to minimize. For minimization, we look the point which give us the minimum cost. For maximization, we look to the point which give us the maximum profit. Is it clear? Is it clear? Anybody has a doubt? Is there anyone who has a doubt? Chaitra, good. Pretty V, good. Ashish, good. Pretty As, Smithan, okay. Putul, very good, very good. So now to confirm, I hope you have written down this one. So to confirm if you have understood this one, now my turn is over. Let it be now your turn. Let me try to find one of your exercise so that you can try to deal with, okay? You can try to solve it, all right? Okay, this is going to be your exercise. As I still have like a few minutes, let me give you your exercise here. Correct? Is anybody who has a question? From yesterday I gave you assignment. You did not show. So I would like to request Ashish, please Ashish, share your answer, please. Ashish, share your answer through your camera so that we can see your answer. Ashish, I'm going to point now to Ashish so he can show what he has done. Like I think Chaitra Pishi tried, but she couldn't. And I think who else? Someone else, he can remind me his name. Ashish, please, you can come on video mode and you
Yes,
turn
sir.
your answer. Yes, please. Turn your rear camera so that we can see. I can now let me focus on Ashish. 1 second. Okay. 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 As all of you can see, this is Ashish's answer. You can slide, you can go, okay. Come to the graph, yes, that's obvious. Come to the graph, yes. Okay, that's a feasible region. Everybody has seen the same. Please try to make it a bit far so that we can see the whole of graph. Push it back so we can see the whole of graph. Yes, again, push it back. Push back of your camera, non front, yeah. Push again. Okay, push until we see the whole coordinate. Push all of it. We want to see the two axes, x1 and x2. That's why I want you to take your book file like in a distance, like you want to take a selfie. Take it a file, okay? All right, okay. As you can see, this is a region, okay? This is a region, a feasible region, which all of you were supposed to have. So I appreciate Ashish did the best. I don't know if anybody has done. Okay, I did not see Diva Surya, Smithan, Pretty As, Nisi, Putul. Thank you, Ashish. So that should be your answer for yesterday's equation, okay? Now for your today, since the time is up, now for your today's work for minimization, okay, for minimization, I want you to do this one, okay? This is for your better understanding. We want to minimize z is equal to 4x1 plus 6x2, okay, subject to constraint. What is subject to constraint? x1 plus x2 is greater than 8, okay? And we have also 6x1 plus what? Plus x2, okay, is greater than 12, where x1 comma x2 is greater or equal to 0. So this should be your, okay, this one solve. Let me write here, solve LPP, okay, by what? By graphical method. By graphical method, okay, by graphical method. Solve LPP by graphical method. Please do it. Don't sleep without doing it. Don't eat without doing it, so that I can evaluate how far or how much you have understood. So is there anybody who has a question or a doubt for this point? Then if there's nobody, then it seems that all the points or the, yeah, yesterday, one more thing also to say, I appreciate Alan. Yes, Alan, he did the best. Yesterday, Alan was asking about the signs, okay? He said, from my childhood, I have learned that when we have both sides, let's say 1x1 is greater than -2, okay? He said, since both contain the sign, then there's no point of changing. But in a matter of fact, when a variable has a sign, has a negative, then it has to change the sign. This has to be positive like this. So since even both they have sign, for the graphic purpose, it has to change the sign. So if you counter the same, if you find more, then you can tell, all right? Then you can tell. Why? Because I considered this as to be what? I considered like this, for example, this it carries -1, okay? It carries like -1 here, okay, -1 here. So when we divide this one, let me say we want to divide the minus x is still there, okay? Divide, okay, which is equal lesser than -2, divide 1. So since the sign is still there, if it comes, it has to change the sign here. So it has to change the sign, and we have x, okay, should be greater than 2. Okay, we can have a positive. All right, so that's it. Why? Because remember, you cannot divide what? You cannot divide a negative number. We divide a positive number. I think we have a positive number. Yes, when you want to have, yes, we don't divide negative number, should be a positive number. All right, so there we go. So if you have any question, or if you have anything to say, okay, let me give you time to solve this one, okay? I would like to give you time to solve this one so that you can, enjoy your day, all right? So if there is no more question, let me wish you to have a very good day till we meet for the next class.
Thank you, sir.
You're welcome. You're most welcome. So as for the next topic, I will go on to the next topic. Don't miss any class. I will go to the high topic. Now, when we want to solve 3 variables, as you can see here was a 2. We have 2 variables, x1 and x2, 2 variables. Now we want to solve like x1, comma, x2, comma, x3. Okay, x3. So these are the 3 variables. So we shall see them. So do the assignment which I gave you till we meet.
Thank you, sir. Thank